In this video, I will show you how to solve a variety of right triangle problems using sine, cosine, and tangent. You might hear me refer to the word SOHCAHTOA, which is really a mnemonic device to help me remember the definitions of sine, cosine, and tangent. These definitions are based on picking a particular angle, and once you've picked an angle, the side across from the angle is opposite, the side that's close to the angle is adjacent, and the side that's across from the 90-degree angle is the hypotenuse. So with that in mind, the sine of the angle is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA will help you remember that because the SOH stands for sine is opposite over hypotenuse, the CAH stands for cosine is adjacent over hypotenuse, and the TOA stands for tangent is opposite over adjacent. So, if you remember SOHCAHTOA and how to spell it right, you've memorized all three definitions. So, we will use this triangle to answer the first few questions. For the triangle above, which is true? Alright, so it's all about angle L, so I'm going to go ahead and circle angle L, and the side across from the 90-degree angle is the hypotenuse, and the side across from the angle, alright, this side over here is opposite, and this side over here is adjacent, right? The one that's close by is adjacent. So the two numbers that I have are the adjacent and the hypotenuse. So that tells me that the cosine of L is equal to 7 over 16, adjacent over hypotenuse. So that answer is B. Alright, for problem number 2, for the triangle shown above, which of these must have the same value as cosine M? Alright, so we have two complementary angles. We have L and we have M. Alright, they are the two small angles in the right triangle. So we have L and we have M. So keep that in mind. So we have learned that the cosine of one angle is equal to the sine of the other angle. So the cosine of M should equal the sine of L. So this must be true. Okay, number 3. For the triangle shown above, what is the length of side KM? Alright, KM. So let me erase all of this and start over. So if we're being asked for KM, alright, I'll just put an X right there. So that means we're given two sides and we're looking for the third. Whenever this happens, we are to use the Pythagorean theorem. A squared plus B squared equals C squared. Make sure that you put the hypotenuse as the C squared. So this is going to be 7 squared plus X squared equals 16 squared. So that's going to be 49 plus X squared is equal to 256. Alright, subtract 49 from both sides. So that's 207. Take the square root of both sides. Whenever you take the square root and you get a radical like this, just hit this button. So 14.387, which is A. So for problem number 4, we are supposed to find x. So let's go ahead and circle this angle. So this x is across from the 90 degrees, so it is the hypotenuse. The 17 is across from the angle that I circled, so it is opposite. So when I talk about SOHCAHTOA, I'm looking for the one that involves opposite and hypotenuse. That's going to be this one. So that tells me that the sine of 52 is going to equal opposite over hypotenuse, so that's 17 over x. When the variable is in the denominator, that's when you swap these. So the new equation will be x equals 17 over sine 52. And that can just go in the calculator. 17 over sine 52. So that's 21.573. So number 5, again we're finding this length x. So I'm going to circle this angle, and the 26 is the hypotenuse. And if I draw an arrow over here, this side over here is opposite, which means that this side right here must be adjacent. So the x and the 26 are adjacent and hypotenuse. That is the cosine function. So I will write cosine 61 is equal to adjacent over hypotenuse. Now, when the variable is in the numerator, that's when you multiply both sides by 26. So that would give me 26 cosine 61 is equal to x. And again, we got that by multiplying both sides by 26. Alright, because those will cancel each other out. So anyway, you can just put that in your calculator, 26 cosine 61. So 12.605. Alright, so number 6, here's the angle. I'm going to go ahead and circle it. The hypotenuse is across from the 90-degree angle, so this is the hypotenuse. If I draw an arrow from the angle that I circled, that always points at the opposite leg. The other leg is adjacent, the one that's close by. So opposite and adjacent, that is the tangent function. So I will write the equation tangent x is equal to opposite over adjacent. So when the variable is inside the trig function, this is when we use the inverse trig function. So I will write inverse tangent, and then these two switch places, so it will be inverse tangent of 15 over 22 is equal to x. And you can just put this in your calculator. Alright, so inverse tangent, so I'll do second tangent, and I believe it was 15 over 22. I have to double check when I go back. So 34.287, got to round up, 34.287. Alright, use this triangle to answer all the questions on this page. Find the length of side UT. So UT is right here, so I'll just put my x right there. Now the hypotenuse is over here across from the 90-degree angle, so just keep that in mind. I'm going to circle the angle and draw an arrow. That will always point at the opposite leg. That means this leg is adjacent, the one that's close by. So I've got opposite and adjacent. that is the tangent function at work. So the equation is tangent 63 is equal to opposite over adjacent, so that's going to be x over 17. When the variable is in the denominator, you multiply by the denominator on both sides, so that will give me 17 tangent 63 is equal to x. $33.364. For number 8, we are supposed to find the length of side US. So I've erased the work from the previous problem, and US is right here, so that's where I will put my x. Now this x is the hypotenuse, because it is across from the 90-degree angle. If I circle this angle, if I were to make an arrow, this would be the opposite side, the one that's blank, which means that the 17 is adjacent. So we've got adjacent and hypotenuse. Alright, adjacent and hypotenuse, that is the cosine function. So I'm going to say cosine of 63 adjacent over hypotenuse, so 17 over x. When the variable is in the denominator, that's when you can swap these. So the equation will become x is equal to 17 over cosine 63. So 17 over cosine 63. 37.446. Got to round up. 37.446. Number 9 says find the measure of angle U. Alright, so we're supposed to find this. But we already have the measure of the other acute angle in the triangle, which is 63. So all I have to do is subtract 63 from 90, and that should give me angle U. These are complementary. So all we have to do is 90 minus 63, and that's it. So that's 27 degrees. Alright, number 10, circle all of the equations that are true, and there could be more than one. Okay, let's see, is this one true? So sine of x. So I'm going to circle x, and I'm going to note that this is the hypotenuse. If I draw an arrow from here, that makes this is opposite, and so that means this leg is adjacent. So because of SOHCAHTOA, I know that sine is opposite over hypotenuse. So that would be 72 over 89. Alright, so this is true. Sine of x is equal to 72 over 89. Okay, let's look at this one. We've learned that the sine of one angle, okay, if we're talking about the two acute angles in a triangle, in a right triangle, they're complementary, and we've learned that the sine of one angle is equal to the cosine of the other. So 36 and x are the complementary angles of this right triangle. So the sine of one angle should equal the cosine of the other angle, so that means this is true. Alright, tangent of 36. So here's the 36. This is still the hypotenuse. If I draw my arrow, that makes this is opposite, and the 72 is adjacent. So the tangent is opposite over adjacent. So that would be y over 72. And that's what we have. So that means this is also true. Okay. And last, we have something that is set up like the Pythagorean theorem. A squared plus b squared equals c squared. But how do we know which one is the c squared? Well, the c squared, the one by itself, always has to be the hypotenuse, which is 89. But 89 is not here where it should be. So this one should not be circled. This is not true. If we did do the Pythagorean theorem, it would be 72 squared plus y squared equals 89 squared. For number 11, we have the double triangle scenario. The best thing to do is to redraw this picture showing the triangles separately. So here I have split the image apart into the two separate triangles. Now, the triangle on the left has enough information for us to solve, only one variable. The triangle on the right has two variables, so we'll have to deal with that later. So, we will use our SOHCAHTOA skills. If I circle this angle and draw an arrow, that tells me that this is the opposite leg. This is the adjacent leg. I know that this is the hypotenuse, so that's not the adjacent leg, it's this one. Alright, so I've got opposite and adjacent. That is the tangent function. So I'm going to write tangent 67 is equal to opposite over adjacent. Now, when the variable is in the top, that's when you multiply both sides by the denominator. So multiplying by 16 will give me 16 tangent 67 is equal to x. And I can just put this in my calculator. 16 tangent 67. 16 tangent 67. 37.694. Got to round up. 37.694. Okay, so that's x. Now, because we just found x right here, we can go ahead and now use that on the other triangle. So we don't have to leave this a variable anymore. We can now go ahead and write 37.694. Alright, now we have enough information to solve the right triangle. Get it? Right triangle. Anyway, here's the angle that we have. If I draw an arrow away from it, that's going to be over here. So this would be the opposite side, which makes this over here the adjacent leg, because this is the hypotenuse across from the 90 degrees. That's always the hypotenuse. Now the opposite side over here is blank, so it's not going to be involved in the solution of this problem. So that tells me that it's all about adjacent and hypotenuse, and that is the cosine function. So I'm going to write cosine 59 is equal to adjacent over hypotenuse. When the variable is in the denominator, that's when you swap these. So that's going to give me y is equal to 37.9, whoops. I meant to say 694 over cosine 59. I forgot what the number was. 59. So 73.187. Got to round up. 73.187. All right. Okay, a 12-foot ladder leans against a wall. The ladder forms a 70-degree angle with the ground. How high up the wall does the ladder reach? Okay, so let's draw some stuff. First of all, here comes the ground. All right, this will be the ground. And now I'll draw the wall. Alright, so this is my wall. And now I will draw the ladder. Alright, and I'm just going to put some little marks on here just to remind us that that is the ladder. Okay, now what did they tell us? They told us that it is a 12-foot ladder. So that means that this is 12 feet. And the ladder forms a 78-degree angle with the ground. So here's the ground. So the 78 is on the ground. So there's a 78-degree angle. How high up the wall does the ladder reach? The height of the ladder on the wall will be this X right here. So we will now use our SOHCAHTOA skills. Let's see. If I circle this angle, well, let's get the hypotenuse out of the way. This 12 is the hypotenuse across from the 90-degree angle. If I draw an arrow going away from my angle, it will always point at the opposite leg. And I will ignore this other leg. This adjacent leg is blank. So we've got opposite and hypotenuse. Opposite and hypotenuse. That is the sine function. So I will have sine 78 is equal to x over 12, opposite over hypotenuse. When the variable is in the top, that's when you multiply both sides by the denominator. That will give me 12 sine 78 is equal to x. And you can put that in your calculator. So that's 11.738. A radio tower is 20 feet tall. When the sun's angle of elevation is 16 degrees, how long is the radio tower's shadow along the ground? Okay, so we've got this radio tower. So first we're supposed to pick the diagram that was drawn correctly. They all have a 20-foot radio tower, so that's great. How about the angle of elevation? The angle of elevation should be right here on the ground. So right away, that eliminates C and D because they have the angle of elevation in the wrong place. How long is the tower's shadow? Along the ground. See, they shouldn't even have to say that. Of course, the shadows are on the ground. So this is what we're looking for. So the X should be on the ground where shadows live. So that is A, that has the shadow in the right place. All right, there's no shadow in the air. So now we will use the picture we chose to answer the question. Well, this blank side here is the hypotenuse, which is across from the 90-degree angle. If I circle the angle that we've got and draw an arrow, that arrow will always point at the opposite leg. The other leg is the adjacent leg. Now the hypotenuse is blank. It doesn't have a number or a variable that we're looking for. So I'm just going to ignore that. So we have opposite and hypotenuse. So if I think to myself, SOHCAHTOA. Adjacent and opposite. Alright, that is the tangent function, involves opposite and adjacent. So that's why I'm going to write tangent 16 is equal to 20 over x, opposite over adjacent. When the variable is in the denominator, that's when you swap these. So that will give us x is equal to 20 over tangent 16. $69.748. Eric's eyes are 5.9 feet above the ground. He stands at the free throw line, which is 15 feet away from the goal. And he looks up at the hoop. The angle of elevation from his eye level is 16 degrees. How high above the ground is the hoop? So we're trying to find this question mark here. But the question mark is not part of the triangle that we have. So we're going to have to do an extra step on this problem. So first of all, let's highlight the triangle, right? Because this unit is about right triangles. So of course we're going to be solving a right triangle. So here is the right triangle that we will be solving. So we know the bottom of this triangle is 15, because that's the same as the 15 that's down here. We do not know this vertical side of the triangle. But if we find that out, we will be able to find the height of the goal, because all we'll have to do is add the 5.9, and then we add the x, and that should be the total height of the hoop. So that's our strategy. So let's go ahead and solve this like we always do. We will circle this angle. We will notice that this blank side over here is the hypotenuse, but because it's blank, I'm going to cross it out. If I draw an arrow away from the angle I circled, that is always going to give me the opposite side. The other leg is the adjacent leg. So, opposite and adjacent. So if I think SOHCAHTOA, opposite and adjacent, that's the tangent function. So that's why I will write tangent 16 is equal to x over 15, opposite over adjacent. When the variable is in the numerator, that's when you multiply both sides by the denominator. That will give me 15 tangent 16 is equal to x. .301. Okay, I almost wrote that right here, but don't forget this is not the final answer. Alright, so that would have been a mistake. Right, 4.301. Okay, so that is x, but the total height of the hoop is going to be an extra 5.9 feet. So I need to take this and I need to add 5.9 to it. So that will be 10.201. Alright, let's do one more trigonometry problem, and then I have a couple review problems that I'm going to do. But if you're here for the trigonometry, this is the last trigonometry problem. So really this is two triangles that are overlapping. So whenever you have two triangles, the best thing to do is to draw the two triangles separately. So here are the two triangles I'm talking about. So here's one triangle. And I'm just going to copy it and move it over. And here's the other triangle, which is the larger triangle. And I will just copy it as well. See how much space do I have for this. Alright, I'll just put them both side by side. Okay, so we need to solve these triangles. Let's go ahead and fill in the information that we have. On the small triangle, I know that this is 64 and this is 165. Okay, on the large triangle, I know that this is x. Okay, and I have some other information here as well that I will get to later. Oh, one more thing. On the large triangle, this 165 is also here as well. So 165. Now our goal is to find x, but right now there's not enough information. I only have one side, I have no angle. I either need to find the other side or I need to find one of the angles in this triangle. So at a glance, I don't see any way to find the other side, but I think I can see a way to find the angle. So imagine that I found this angle right here. I'm going to call it y because I already have an x. Imagine that I found this angle in the small triangle. Now, can you see that this angle y is right here in the combined picture? So if I found y, then all I would have to do is add y and 26, and that would give me this angle right here. And then once I have that angle, I can use my trigonometry to find x. So that's my strategy. So first, let's find y. Now, notice that this is the hypotenuse right here, across from the 90-degree angle. It is blank, so I won't use it. If I draw a circle around my angle and draw an arrow going away from it, that will tell me that the 64 is the opposite leg, and therefore the 165 is the adjacent leg, the one that's close by. So, as we've done many times before, we will think so, ka, toa. Opposite and adjacent. That is the tangent function. Alright, so that's why I'm going to write tangent of y is equal to 64 over 165. Alright, opposite over adjacent. When you want to solve for a variable that's inside the trig function, that's when you do the inverse trig function. So I will do inverse tangent, and then these two switch places, so I will have the 64 over 165, and that will equal y. And I can just put this in my calculator. So inverse tangent, what was it? 64, 165. Okay, so 64 over 165. So that's 21.200. Okay, so and I should say degrees. Just double checking, 21.200. Okay, so that tells me that this little angle y right here is, and I'll just say 21.2 degrees. So if I add these together, that's going to give me the measure of this this angle of the larger triangle. So that should be 47.2. So this angle right here should be 47.2 degrees. So now I have enough information to solve this triangle for x. Notice that the x is the hypotenuse of the large triangle. It's across from the 90-degree angle. If I circle the angle and I draw an arrow going away from it, that is always going to point at the opposite leg. But this is blank, so I won't use it. The other leg is the adjacent leg. So I've got adjacent and I've got hypotenuse. Adjacent and hypotenuse, that is the cosine function. So that's why I will now write cosine 47.2 is equal to adjacent over hypotenuse. So 165 over x. When the variable is in the denominator, that's when you swap these. So that will give us x equals 165 over cosine 47.2. And we can just put that in the calculator. Okay, so 165 over cosine 47.2. Just double check. So 242.847. Got to round up 5 or higher. 242.847. All right. So that is the last trigonometry question. So if you're here to learn about tangent, sine, and cosine, thanks for watching, and I will see you on the next video. But if you're in my actual class, and maybe you're doing recovery or something because you didn't do well enough on this test and now you need to retake it or something like that, then you might want us to see these last two review questions as well. So you can just keep on watching. So let's see. Dilate triangle ABC from the point 6, 3 by a scale factor of 2/3. Okay, since we're dilating from a point that's not the origin, that means we need a fake x and y axis. So the point 6, 3, alright, so here's the point 6, 3. So I'm going to use that as a fake origin. So there's my fake x-axis, and here's my fake y-axis. Alright, so what are the coordinates, the fake coordinates? Alright, I'm going to use lowercase letters to sort of remind me that these are fake. They're not the real coordinates. So, the fake coordinates of point A, if pretending that this is the x-axis, that would make this, let's see, so -6, 7, 8, 9. That would make this -9, 0. And then B, fake B. So this would be -6, -6. It's left 6 and then down 6. Alright, so fake B is -6, -6. And then how about fake C? Alright, well fake C is left 9 and down 6. So -9, -6. So these are the fake coordinates of these 3 points. So when you're dilating by a certain scale factor, all you do is multiply everything by that scale factor. Alright, so if I want to find A prime, well, fake A prime, but still, I'm just going to multiply both of these numbers by 2/3. So -9 times 2/3. Alright, so -9 times 2/3 is -6. So I'm going to get -6. 2/3 times 0, alright, and maybe I should just show that I'm multiplying everything by 2/3. Alright, that's all I'm doing. So 2/3 times 0 is just going to be 0. We know this. So then fake B prime, if I multiply -6 times 2/3, alright, so if I take -6 and I multiply it times 2/3, that's -4. So I'm going to get -4 and -4 again. So I won't have to go back to my calculator for fake C prime, because we already saw that if you multiplied by -9 times 2/3, you got -6. And if you multiply -6 times 2/3, we got -4. So we already know that. So these are the fake coordinates of the image. So we can graph these as long as we keep on using our fake axes. These are fake coordinates, so we use the fake axis. So -6, 0 would be right here. I feel like I should change colors. Okay, -6, 0 would be right here. -4, -4 would be right here. And -6, -4 would be right here. Okay, so this purple triangle is the image. Okay, so this will be our A prime, B prime, and C prime. All right, last one. Apply the transformation to triangle ABC. All right, so we won't need any fake axes or anything like that. We can just use the actual coordinates. So what are the coordinates? Well, you know what? I don't think I'll even just do the math. So if we're doing +4 to the x, we understand that this is going to move it to the right 4. If we do +2 to the y, it will move everything up 2. So I think it'll be quicker if we just move all the points right 4 and up 2. So if we take this and we move it to the right 4 and up 2, that'll be here. So we'll just do that over and over again. So if I go to the right 4 and up 2, and right here, if I go to the right 4 and up 2, I don't see why we need to make it any more complicated than that. Okay, so this will be our A prime, B prime, and C prime. All right, and that's it. That's all we were asked to do. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.